my name is Kissner, and today I will be reporting on the jet engine experiment, experiment 7. The overview is the introduction, then we're going to go over some objectives, apparatus, experiment, data analysis, and then conclusion. So the experimental objectives the main purpose of the jet engine experiment is to allow the students to better understand operating principles of a jet engine. First, we recorded temperatures and pressures in the lab, and finally we analyzed all the data. So, I know Philip's presentation was really cool because he had a guy actually get sucked into one of these, but my cousin actually used to work at the airport, and he said basically if 1 penny got sucked into like a jet engine on an airplane, the engine would explode. So I thought that was really interesting, just in the fact that something so little could bring an airplane down or cause it to not take off. Anyways, this is the actual jet engine we used during the lab. These are the Type K thermocouples, and we're going to talk a little bit about the combustor and nozzle and the compressor later on. So this is the jet engine cycle. The black is the theoretical cycle, where the blue is the real life cycle. So from 1 to 2 we have a constant entropy. From 2 to 3, we have a constant pressure, and then back down 3 to 4, constant entropy again, and 4 to 1 is another constant pressure process. In theory, as efficiency of a jet engine increases, so does the pressure ratio. The jet engine cycle can be seen right here. Here's some useful formulas. First, we use energy released in the nozzle in fraction form. The next set of formulas is energy released in the combustor in fraction form. Third is exit velocity, which is thrust over mass flow rate, and the last is the first law. So here we have some data. You can see as mass flow rate increases as RPM increases. I have this weird data point right here, and we'll see that later on. I don't know if it's an outlier or what it is exactly, but anyways. Oops. The next is thrust as a function of RPM. The line on the top is the measured thrust, and the line on the bottom is the calculated thrust. So as you can see, the actual measured thrust was greater than the calculated. And thrust also gradually increases with RPM. This is a fraction of fuel used versus a function of RPM. You can see that the combustor uses a way larger fraction of fuel than the nozzle, than either of the nozzles. And this shows component work, where this is the turbine component work versus RPM. And this is the compressor component work. As you can see, the compressor has a negative component work. This is the isentropic efficiency, and it kind of bumps around. Here's that weird data point again. With that, are there any questions?